In this lesson, we'll continue our review of Math Test 10, Section 4, Calculator Permitted. We're still in the early part of the section, questions 6 through 9, so not too difficult yet. Problem 6, which of the following is equivalent to this equation? And we just simply distribute, right? 2x times x squared, we know that's 2x cubed, and 2x minus 3x, that is minus 6x squared. D is the answer. All right, let's take a look at the next one, number 7. A retail company has 50 large stores located in different areas throughout the state. A researcher for the company believes that employee job satisfaction varies greatly from store to store. Which of the following sampling methods is appropriate to estimate the proportion of all employees of the company who are satisfied with their job? So there will be a few questions on sampling, and whenever you have a sample, you always want to make sure it accurately reflects the population. The sample, remember, is like a subset. We're not asking every person in the population, we're asking a group. And if it is a fair sample, if it's random, then it can be a good representation of the entire population. And so 50 stores located in different areas throughout a state, and we want to see, the company wants to find the satisfaction from store to store. So let's take a look at the sampling methods. Selecting one of the 50 stores at random and then serving each employee from that store, of course not, because we want to determine how satisfaction is at all the stores. So why would we ask one? That's not a fair representation. Selecting 10 employees from each store at random and then serving each employee selected. This looks pretty good, right? Because asking every store and not just one employee, because it could be skewed, but 10, and then asking those 10 to complete a survey. This looks pretty good. Serving the 25 highest paid employees and the 25 lowest paid. No, that's not a fair representation, right? The highest paid employees probably have more satisfaction, I would guess, than the lower ones, but it's just not fair. You want a complete random cross-section of all employees. That's what the purpose of the survey to determine. And then D, creating a website in which employees can express their opinions and then using the first 50. Of course not, because who knows who would respond. It could be skewed to people who use the internet. It is not a fair random cross-section. So it's definitely B for number 7. All right, let's go back up to question 8. The two graphs above show the total amounts of money that Ian and Jeremy have deposited into their savings account for the first 7 weeks after opening their accounts. After they made the initial deposits, how much more did Ian deposit each week than Jeremy? So the initial deposit, remember, this is the y-intercept. This is when the amount they both started. So they started at different amounts, but the question is just asking how much more did Ian deposit each week than Jeremy? So we look at these lines and we see that Ian, even though he started with a lower initial amount, let's just figure out what the amount he contributed per week. And you don't really need to use the slope formula. If you just look, this is 1 week and he went from 100 to 200. That's an increase of 100. And then another week, he went from 200 to 300. So Ian is depositing $100 per week. And then let's take a look at Jeremy. So he started a higher amount, it doesn't matter. And this looks after 1 week to be between 300 and 400. It looks like 50. But then if you jump ahead to 2 weeks, you see he's right at 400. And so it took him 2 weeks to increase 100. And so then Jeremy is only $50 per week. And so how much greater is Ian than Jeremy? It is 50. All right, one last question on this page. Let's take a look at number 9. So these are a little bit out of order from the way they appear in the book. All right, here we have h of x equals 2 to the x power. The function h is defined above. What is h of 5 minus h of 3? And so all we have to do is substitute h of 5 initially, solve it, and then subtract h of 3. You definitely cannot just find h of 2. You cannot subtract here because these are exponents, right? And so the property, it doesn't work that way. You have to do each one independently. So let's just do h of 5. So here's the x. We plug in a 5, and whenever we see an x, we plug in a 5. So we know that h of 5 is simply 2 to the 5th. And you could use your calculator, but that's 32. And then h of 3, now we're plugging in a 3 here. And that's just 2 cubed, which is 8. And we want to just subtract h of 5 minus h of 3, so it's 32 minus 8, and the answer is 24.